Hey, what is up everybody? It is Mr. Boylan and we're back for some more stoichiometry. First things first, as we take a look here, it says the first step in the industrial manufacture of nitric acid is the catalytic oxidation of ammonia as shown in the equation below. The reaction is run using 852 grams of ammonia and excess oxygen. Whew, lucky for us, we're provided with a balanced chemical equation, so we don't need to worry about that here. But as we look at the first thing we're asked to do, we're asked to determine how many moles of NO are formed. Now, as you take a look in this problem, we are starting with a mass in grams, 852 grams to be exact, of ammonia. This first part asks us to determine the number of moles of NO. I'm going to set up a conversion factor here. In this first example, I'm going to put grams of ammonia, NH3, the exact same unit on the denominator so that unit will cancel out. Now here's where we have a switch from those previous types of problems. Now we're going from grams of one substance to moles of something else. So before we can go directly to moles of that other thing, we need to first go to moles of the thing that we have. And the reason why that is because these coefficients in the balanced chemical equation relate to us the ratio of moles, not the ratio of grams. Not the ratio of moles of one thing to grams of something else, but moles to moles. Pretty much for the majority of the rest of this year, if you don't know what to do, solve for moles of whatever you're given, and that'll get you where you need to go. All right, now before I plug in any numbers, I recognize that the unit of grams of ammonia will cancel out. And I'll be left with, when I solve this, moles of ammonia, which is great, but I'm looking for moles of nitrogen monoxide. So I'm gonna set up a second conversion factor. Again, imagine a second fraction. This time, I'm going to put the unit moles ammonia in the denominator. I'm going to put moles of NO in the numerator. Now that I'm working in moles, I can easily compare to any other substance in the chemical equation. But first, you've got to have moles. This second conversion will cancel out the unit of moles of NH3 and it will leave me with moles of NO. Let's plug in some numbers so we can solve. Mole to gram relationship. Where can I find that understanding? You got it, the periodic table, which always tells me the relationship in 1 mole to the mass in grams of whatever it is that I'm working with. So as I look at my periodic table, I'm trying to determine the molar mass of NH3. I need to combine the masses of 1 mole of nitrogen and 3 moles of hydrogen. I'm going to bust out my handy dandy calculator, 14.007 plus 3 times the molar mass of oxygen to come up with a molar mass of ammonia to be 17.031. I simply plug that into my conversion factor for the molar mass of ammonia, and then I continue on my way. Now I've got a mole to mole relationship, which comes from the balanced chemical equation in the problem. I've got 4 moles of NO to 4 moles of NH3. Now to speed things up, I'm simply going to put this into my calculator, but if you have questions about how dimensional analysis works, be sure to either rewatch that video on dimensional analysis or come in and get some tutorials. So in my calculator, I'm simply going to multiply everything across the top. I'm going to put a parentheses there, times 1 times 4, close parentheses, and divided by the product of everything in my denominator. 17.031 times 4, close parentheses, solve. So by using dimensional analysis, I determined that I will end up with 50.0 moles of NO. That is my final answer, rounded to the correct number of significant figures. And if you question whether or not your answer makes any sense, go back to the original amount that you're provided, 852 grams. You know, that's a lot more than the mass in grams of 1 mole of ammonia. In fact, it is 50 times larger. In other words, I have 50 moles of NH3 in this 852 grams. And the relationship between NO and NH3 is a 4 to 4 or 1 to 1 relationship. So however many moles of NH3 I have, I'm also going to have that same number of moles of NO. All right, let's move on to the last problem for the day. It's a doozy. It says tin 2 fluoride, SNF2, how nice of them to give you the nomenclature, is used in some toothpastes. The next time you're brushing your teeth, you could be studying nomenclature. It is made by the reaction of tin with hydrogen fluoride according to the following equation. Wow, this is so nice. Twice in a row that I'm given an equation. It says how many grams of SnF2 are produced from the reaction of 30 grams of HF with Sn. Whew, oh my goodness. So since we already have the balanced chemical equation, the next thing we're going to do is start with the amount that we're provided with in the problem, which is 30.0 grams of HF. I'm going to set up a conversion factor in which I put that same unit in the denominator of that first conversion factor. Since it's not moles, I have to go to moles of that initial substance first. That will cancel out the grams of HF, but I need to set up a second conversion factor so that I can go now from moles of HF to moles of what it is that I'm looking for. In this case, I'm looking for, wait a minute, grams of SnF2. Before we can get to grams of SnF2, we have to go to moles of that substance. Again, because the relationship that exists between the different things in a chemical reaction is a mole ratio. So you always have to compare one thing to something else in terms of number of moles. So that will get moles of HF to cancel out. But now I'm left with moles of SnF2. So I need a third conversion factor in which I put moles of SnF2 in the denominator and grams of SnF2 in my numerator. This will cancel out the moles of SnF2, and I'll be left with the unit of grams of SnF2, which is what it is that I'm looking for in this problem. Now I have a mole to grams relationship here. 1 mole of HF, I can determine that relationship by looking at the periodic table. As I look at the periodic table, again, I'm trying to find the molar mass of HF, which is just 1 mole hydrogen, 1 mole fluorine. I'm going to use my handy dandy calculator here, 1.008 plus 18.998 gives me a molar mass of 20.006. 20.006 is the mass of 1 mole of HF. Now I'm comparing moles of HF to moles of tin 2 fluoride. That relationship is going to come from the balanced chemical equation. As I compare those two things, for every 1 mole of SnF2 produced, I need 2 moles of HF. So I'm only going to make half the number of moles of SnF2 as HF that I started with. My final conversion factor is once again a mole to gram relationship here. Once again, I need to go to my periodic table of the elements. This time I'm trying to determine the molar mass of SnF2. I'm going to add together the mass of 1 mole of tin, which is 118.711 grams. I'm going to add to that 2 moles of fluorine. Solve, and we end up with a molar mass of 156.707 for my tin 2 fluoride. At the same time, I'm going to plug this into my calculator, but I'm going to show you a new method. Instead of multiplying everything across the top and dividing by everything across the bottom, the beautiful thing about math is that I can sort of do it in steps. I like to take whatever number I start with, multiply it by the number on top, and then divide it by the number at the bottom. When you do it this way, you're given the amount after each step. So if I do 30.0 times 1, boom, divided by 20.006. In other words, if I stopped here, I would solve for moles of HF. And think to yourself, okay, does it make sense that I ended up with roughly 1.5 moles of HF? Yes, okay, 1 mole of HF is roughly 20 grams. I have 30 grams, so I should have approximately 1.5 moles here, which I do. Next, I multiply that by 1, so it's always multiply by the numerator, and then divide by the denominator, in this case 2. So again, think about what we solved for. When we stop here, we get 1.5 moles of HF, which means that we'll make 0.75 moles of SnF2. Which makes sense because as you look at your balanced chemical equation, however many moles of HF you start with, you're going to make half the amount of moles of SnF2. As I finish this up here, I multiply that amount by 156.707 and divide by 1. So my final answer is 117 grams of SnF2. SNF2. Boom. That is my final answer that is rounded to the correct number of significant figures. Again, when you do it sort of step by step like this, it's easier to figure out whether or not your answer makes sense. Now, on a multiple choice problem, some of you will be able to do this in your head. You're encouraged to estimate. I might just use exactly 20 grams here, and I might say 160 grams here. That'll make the math a little bit easier. So 30 grams times 1 divided by 20 means I have 1.5 moles of HF, times 1 divided by 2 means I'll get 0.75 moles of SNF2 times 160. Oh, before I push enter, let me just think to myself, well, half a mole would be 80, a quarter of a mole would be 40. So 3/4 of a mole is going to be approximately 120 grams. Whoa, I'm a genius! So on the multiple choice, you're encouraged, and I implore you to just estimate. You'll save yourself a lot of time. The answers on the multiple choice are generally far enough apart that you'll be able to make a determination without using exact figures. I know that many of you are math geniuses out there and can do the math faster than I can. Do it!